Hi, everyone. This is Michael from the Data Incubator. We're really excited to have you for our broadcast, another installation of our series, Data Science in 30 Minutes. So I'm Michael Lee. I'm the founder of the Data Incubator. In case you don't know, we run a fellowship for PhDs and master's students to enter industry as data scientists. It's completely free for the fellows to get in, and you can apply by going online to the dataincubator.com. And we also have a corporate training offering, so if you work at a company or you manage folks and you're thinking, I'd like to get my folks to learn a bit more about data science, you can also go online to the dataincubator.com and sign up there. So today, we're here for a talk about data science in 30 minutes. This is our regular monthly series on data and its role in the world. So past speakers have included Becky Tucker, who is a data scientist at Netflix, Jess Strofe, the VP of Data at Quantopian, Holden Corral, who's an engineer at IBM and one of the core contributors for Apache Spark, Andreas Mueller, who is one of the core developers of scikit-learn, and Sam Swift, who's the VP of Data Science at Betterment, who's also a former fellow at the Data Incubator. So before I introduce today's speaker, I want to remind everyone that you can pose questions in the YouTube chat area. That's the chat area sort of on the right, and we're going to take those questions and we're going to send them to, we're going to sort of pose them to our speaker here in a minute. And so this is a very interactive session, so we really want to get you and encourage you to submit those questions. So you need to be logged onto a Google account in order to do that, but once you do, you can submit your questions. Now, without further ado, I'd like to introduce Greg Piatetsky-Shapiro. So Greg is a well-known data scientist and president of KDnuggets, a leading site, and probably the leading site for analytics, big data, data science, data mining, and machine learning. Greg is a co-founder of KDD, Knowledge Discovery and Data Mining, and is basically the top research conference in its field. And he's also the co-founder and the past chair of ACM SIGKDD, which is the professional organization that hosts KDnuggets. So, sorry, that hosts KDD, my apologies. So without further ado, Greg, I'll let you take it from here.
Okay, well, Michael, thank you, and thanks for Data Incubator for the opportunity. Thought it would be interesting to talk about data science. I used to be the youngest kid in the class, but now I'm among the more veteran data scientists, and I hope that many younger data scientists and aspiring machine learning engineers can learn some interesting things from this webcast. Michael asked me to talk a little bit about my journey to data science. So given that we only have 30 minutes, I try to give a short summary. As a kid, I was very fascinated by sci-fi and loved stories about robots. So that probably motivated me to learn computers when they first appeared in the 70s. And in my first year in college, computers were still programmed with punch cards. I caught that period. I spent several weeks of my free time writing a program to play battleships. I used APL, which was very advanced for that time array programming language with various fancy matrix operators. And after spending 3 weeks, I played this program for 5 minutes and was soundly defeated by my own program in the very first game. Never played it again, but I became much more interested in created programs than playing them. I studied later computer science and received Ph.D. from NYU, and I joined GT laboratories in Boston area and worked on applying machine learning methods to large databases. And in middle 80s, I attended one workshop on something that was called expert database systems. The concept was very fuzzy, and I thought we could do better than talking about expert database systems and find many interesting things in large data. I was not very satisfied with that workshop, and being young, energetic, and naive, as I hope many of our listeners are, decided that I could do better and organize my own workshop. The name data mining was most common name used at that time for this field, and I thought it sounded not exciting enough, so I called the workshop Knowledge Discovery and Data, or KDD. And that first workshop was in a very long time ago, 1989. But it attracted many great researchers. I since after that organized 2 more workshops. And in 1994, one of my best ideas was to hand over the organization to new team. So I recruited Usama Fayyad, who was then just a fresh PhD, and Samu Turusami, who was his PhD advisor and researcher at GM. And they've attended previous workshop, and they organized the next workshop. And 95, the workshop became a separate KDD conference. And 98, Won Kim, who had experience running SIGMOD, kind of a leading group for database research, he helped us create the KDD group as part of ACM. ACM, the leading computing organization, has a number of groups for graphics, for programming languages, and we created a group for KDD, which organizes the KDD conferences and has related activities, including grants for supporting data science research. I think last year we had up to now 22 KDD conferences, and I'm very pleased to see that KDD remains the leading research conference in the field based on citations and other indices. In 93, after the third KDD workshop, I started an email newsletter, KDnuggets News, just to help connect researchers who went to the workshops and discuss topics of data mining and knowledge discovery. The very first issue went to about 50 researchers who attended the workshop. Today, KDnuggets has over 200,000 subscribers across email, Twitter, Facebook, LinkedIn, and RSS. And in the last few months, the KDnuggets website received over 500,000 visitors a month. So quite a bit of growth from 50. And it is a very popular site for data science and analytics news. And our mission, there is a lot of stuff that's covered on all the different news sources, but our mission is to cover what is interesting in the intersecting fields of AI, big data, machine learning, and data science. And besides me, we have another full-time editor, Matthew Mayo, who does an excellent job of editing KDnuggets and writing about them. We have a couple more interns. And another aspect, my activities, besides running conferences and KDnuggets, was also working as a researcher. So I started as a researcher at GT Labs, where we worked on knowledge discovery and data mining. I actually started the first project that was called Knowledge Discovery and Data. Little did I know then I should have come up with the name, data science, or maybe something, big data IoT. But knowledge discovery was a popular name at the time. And in late 90s, after the internet boom, I joined a startup that was doing analytics, data mining, consulting for financial industry. And I was a chief scientist and managed a small team. And our smallest startup was bought by a big startup, and that big startup rose to a valuation of over $1 billion for a brief period of time. But before we could do anything foolish with all those extra paper money, it went all the way from $1 billion to zero. So both sides of those stories were somewhat familiar to me. So when that startup crashed, and after the dot-com crash in 2001, I decided to try doing KDnuggets as a full-time activity. I've been publishing KDnuggets and doing some data mining consulting, but in the last few years, thanks to big data and data science popularity, KDnuggets has become so popular that I now don't do consulting, can only do KDnuggets. So it was kind of interesting to me that the acronyms in this field keep changing. So I went from AI, initially kind of interested in it as a kid, to data mining, to KDD, knowledge discovery and data, and then predictive analytics became popular term. Data science appeared maybe in 2012 and then machine learning, and now last year AI has become the most popular and kind of most hyped term. But the essence is really finding what is kind of interesting in this data and how we can use it. Although I should note that machine learning is not the same in data science. There is a large overlap in methods, but machine learning includes very important subfield where there is an active agent which can do things and learn from experience. So kind of the field of reinforcement learning was started by Rich Sutton, by the way, with whom I worked with at the same GT laboratories quite a while ago. So reinforcement learning may be, a very important field for the next few years, and may hold the key for achieving artificial general intelligence. That's kind of a brief, short story of my progress from AI to data science and back to AI. So I had some notes on some interesting trends in AI, but Michael, I don't know if you have any questions.
Oh, we have lots of questions for you.
Okay.
Yes, no, I mean, look, this is a really great story, and I think it's always wonderful to talk with someone who's made that transition from punch cards to the cloud. And in that time, I think you alluded to earlier, we've used a lot, we talked about sort of this thing in a bunch of different names, right? We've used the terms data mining, business intelligence, predictive analytics, data science, machine learning, artificial intelligence, just to name a few before I run out of breath. So how do you see the difference between these between all these terms? And, what do you think, what advice would you give people for how they should brand and position themselves?
Yes, by the way, this hat that I'm wearing, this is a data mining hat. Although now data mining is less fashionable, so maybe people should wear data scientist hats. I think in terms of branding, well, I would advise data science people who want to be data science just to work on solving some real problems, not worry as much about what it is called. This is the domain of people in marketing. Now, if you add to anything, blockchain, AI, and IoT, the valuation of the firm rises immediately. But, the hype may be exceeding reality. AI and, deep learning methods definitely have achieved tremendous success. But I'm concerned that now AI is so overhyped that it's exceeding the ability to deliver for, especially in the enterprise. Now I have a new beast that has appeared called enterprise AI. It's potentially very promising, but because it promises so much, there is a danger that it may not be able to deliver. So I would put a caution flag next to enterprise. I think eventually it will happen. I'm just not sure if enterprises are ready yet.
I mean, that is a conversation we have quite often, especially as we talk with a lot of our corporate clients, is sort of both the hype cycle, right, as well as the sort of how do you truly adopt data science within an organization. And that's actually one of the questions that was posed is how, I think we've all seen the Gartner hype curve, right? Sort of peak inflated expectations all the way down to the trough of disillusionment. Where do you think we are now in that curve? And where do you think and how far do you think enterprises have to go or not in terms of enterprise adoption of this stuff?
Well, I noticed that big data term was dropped by Gartner from its hype curve around 2015 and was replaced by something called, machine learning, and they even had something called like citizen data science. I think, the technological trends of AI kind of moving inexorably and inevitably. We now have kind of invasion of AI into our homes with, with Google and Alexa, and you now have to say those names very carefully because you may activate the smart speakers in rooms. So I think AI kind of moves into homes maybe sooner than AI moves into enterprises, because with enterprises, the difficulty is really changing the organizational structure. How do you manage something that works on machine learning and is self-improving? How do you manage something that takes away different jobs? Those are very difficult questions. I don't pretend to know the answers, but I think the enterprises and companies definitely should think about those, and they should be aware that the capabilities may be increasing unequally and faster in some areas than others. And if I may, I just wanted to tell one very interesting story about amazing advances in AI, specifically related to chess. Back in, I think, the very first workshop where the word AI was coined in 1956, kind of the original researchers like John McCarthy and Oliver Selfridge, they probably, and Marvin Minsky, they probably thought that AI could defeat chess champion by 1960. So they predicted would happen something like 10 years. And in 1970s, people laughed at them and said, AI will not be able to do that. And in 1980s, people were still laughing. By 1997, people stopped laughing because by that time, IBM Deep Blue was developed over several years, but it defeated the world champion Garry Kasparov. And last year, December 2017, the strongest chess player was a program called Stockfish, who learned all the human expert opening and searched tens of millions of positions for every move. But in 2017, DeepMind, which is now part of Google DeepMind, developed a program called AlphaZero, and I'm skipping over the previous iteration, AlphaGo Zero, but the 2017 program AlphaZero, so-called zero because it started with zero human knowledge. It just knew the rules of the game, and it played by itself, in a few million games, and in just 4 hours, it achieved superhuman abilities in chess, and it defeated the strongest chess player in the world, who last year was not a human but another computer program, Stockfish. So what was interesting, not only that it took 4 hours, but also how it played. So Stockfish searched millions, I think like 80 million position. AlphaZero searched 1,000 times less position, but in process of self-play developed very strong evaluation function. What, if humans would do that, we would call it intuition. And I used to be a strong chess player myself, so I played a few of those games, and I was really completely floored. And that was, I think, reaction of stronger chess players, because AlphaZero made some incredible sacrifices that were not obvious. The other computer who looked, like 20 moves ahead and searched 80 million positions could not see what was wrong with accepting that sacrifice. But AlphaZero developed the superhuman intuition, and it won, I think, out of 100 games, it won 26, and all the other games were draws. It did not lose a single game. So when it develops superhuman intuition, it would be hard for humans to understand it, to understand what's happening. So that may be like a short preview of artificial general intelligence. Although I have to say, artificial general intelligence, something that people like philosophers worry about, Elon Musk and Stephen Hawking's worry about it. It will not happen immediately. Ray Kurzweil says it will happen by 2045, and other experts give similar results. We recently had a poll at KDnuggets readers, and we had about 1,200 responses, and the median prediction was it will take maybe 20 to 50 years. So I think for the next maybe 20 years, people are probably safe. In the short term, AI will be a big benefit and will augment human abilities. In long term, if we look at the trends, it will be a serious problem because it will replace many human abilities. Like, what would human chess grandmasters do now that there is a program that has superhuman abilities? So that's a difficult problem for a society, but at least people should think about it and prepare it. But we probably have a few years before this will happen.
So on a slightly different part of the labor curve, so we have a listener who says that they're a master's student in math and business intelligence. And what's your advice to them about how to move into the data science field?
Now there are a tremendous number of tools that are available. R and Python are both very popular tools, although last year, by all measures, I think Python overtook R. Python also has better integration with deep learning platforms like TensorFlow and PyTorch. It's called PyTorch and not RTorch for a reason. So start learning and start doing as soon as possible. There's tremendous number of courses that you can take. There are some free courses. There are degrees, online degrees, and certificates. Learn from the best. Take courses. If you can, learn from Jeff Hinton or Jan LeCun, or from their students, or from Yoshua Benjo at University of Montreal. They're kind of the leading researchers in deep learning, and participate in some competitions. But be aware that most of the kind of interesting work of data scientists is not running a machine learning model, but phrasing the question. I think people said that more data beats better algorithm, with which I agree, but better question beats more data. If you don't know how to correctly phrase the question, it will not be important if you solve it, if it's the wrong question. So kind of try to develop business intuition, how to visualize data. Those are things that would be hardest to automate, because again, it's a golden age for data scientists, but data scientists also deal with a lot of data and has a lot of rules, and those are the professions that are in danger of automation. So there are various companies like Data Robot or H2O that already offer automated machine learning. So for the next few years, I think it will work as an assistant to data scientists, but after 10, 20 years, it may automate most of the modeling activities, but probably not ability to ask the important questions and see how you can use the data creatively.
Yeah. So I think a lot of the questions that we've gotten, I know certainly, have to do with, so do you need to get a Ph.D. to become a successful data scientist? And I think that's maybe particularly true. You alluded to working with people like Hinton, some of the Jan LeCun, some of the sort of real leaders in this field, presumably as sort of Ph.D. students or postdocs. But do you think that's really necessary for becoming a data scientist?
No, I think one word, the PhD, is not necessary. I think you only need a PhD if you're going to teach in academia, but now many people even drop out of master's programs. So if you can actually do real work in data science, it's actually very easy to see if you can code, if you can come up with some interesting application, can master amazing number of those deep learning frameworks, contribute to GitHub, write your own interesting tool, then you could do a good job of data scientist. And I should mention that the top two most emerging, kind of fastest growing jobs in the United States last year, according to LinkedIn, were machine learning engineer and data scientist. Number one and number two fastest growing jobs in United States.
That's interesting. And this sort of points to, I feel like there's sort of almost a dating of these words, and I don't know how much significance you put to them. So, business intelligence and predictive analytics to me seem like they're sort of older terms that are maybe from more like the 80s and 90s. Whereas machine learning, data science, even artificial intelligence now seem like they're more modern terms. Do you see that there's a sort of useful semantic difference between that, those words, or do you think that they all kind of, what are you seeing?
Well, business intelligence is, I view it as more like looking in rear view mirror, kind of more analysis and reports. Things like predictive analytics, data science is concerned more with doing predictions, looking forward instead of into rear view mirror. And machine learning, as I mentioned, is not quite the same as data science because there is a big aspect of dealing with active agents, robots, self-driving cars, which are coming soon, or maybe self-driving trucks, self-flying drones, etc. So this is also an aspect of machine learning, which is not part of data science.
Okay, so you think, so for you, machine learning includes reinforcement learning?
Yes, I think traditionally, if you look at universities which teach machine learning, they would include reinforcement learning there.
And you see it as also including sort of artificial intelligence, or would you say artificial intelligence is the superset?
Well, traditionally it has been used as a superset. I have attended actually the very first conference on AI, triple AI in 1980, and then there were discussions about robots and semantic knowledge bases, etc. So it was always a superset, but AI as a field was losing different subsets. So AI is something that all those other things cannot do yet.
So AI is the data science of the future?
Well, I think AI is probably the most important technology of the future. And, data science is probably more grounded in actual data, while AI may be, flying high with robots and drones.
That's really interesting, because I think that, especially as this field has become more popularized, right, more people are trying to interact with it, and the vocabulary that we use to just talk about it is often very blurred. So I'm always sort of interested in how people talk about these topics. So we have another question from a bioscience scientist. What do you think is the future for open data for human clinical data, and particularly human clinical data, especially with the advancements of electronic health records and wearables and things like that?
I think it's very useful to have open data for progress in the society. I'm not an expert in biology, so I don't know the exact state of it, but definitely it helps research progress when more data is open. Although if you can use open data to engineer some really dangerous virus, then open data may be a problem.
Yes, and that kind of brings us to another question, which is, where do you see the intersection between data science and privacy? Do you think they're always going to be kind of in opposition to one another?
Well, I think we'll need to redefine privacy. I think that ship has sailed now with face recognition working at human or superhuman level. I think people cannot expect kind of the perfect privacy that they used to have, for some period in the 19th century. So I think somebody said that privacy will become a virtue, like when people, 100 years ago or 200 years ago lived in a small village, everybody knew what's happening with everybody else, but it was a virtue, they didn't discuss it. So, or like in Victorian England, you may know that something is happening with your neighbors, but you do not invade their privacy, don't show it to them. So I think likewise, there may be kind of desire for privacy, but people now seem to live their life digitally and leave so many digital breadcrumbs that it becomes very easy to identify them technically, whether they want it or not. Even if they are not on Facebook, but there are, for example, their friends take pictures, there are security cameras, so it becomes very easy to track them. So I think another important issue that our listeners should be aware is GDPR, the European General Data Protection Regulation, that becomes effective in May of this year. And some of the important aspects how it will affect data science, it includes also right of explanation. So if some machine learning program makes a decision to reject you for a credit card, there should be some ability to explain it. I don't know exactly how it will happen, but it will be the law. So companies are working towards satisfying that law.
Yes. I think that will probably be where we have to end it. So thank you everyone for joining us for this Data Science in 30 minutes. We're really excited to have Greg here. Greg, thank you so much for coming and speaking. We had over 1,500 signups for this, so thank you all in the audience for listening. And if you're interested in learning more about the Data Incubator, our free fellowship, or our corporate training, please go to our website, www.dataincubator.com, where you can sign up to learn more. And we hope you're looking forward to our next Data Science in 30 minutes, where we actually have a data-driven journalist from the New York Times coming and speaking to us about how to use data science to solve sort of different, I guess, crack different riddles in and to get us scoops in stories. So thank you so much.
Well, thank you, Michael. Thank you for the opportunity.
All right. Cheers.